Welcome back to Mrs. Lewis's classroom for Physical Science, 9th grade. Our new chapter, chapter 27, is all about Earth's changing surface. Earth's changing surface goes through different materials and processes due to erosion and deposition, and these processes can provide clues to interpret Earth's geological past. So, Earth's changing surface adjusts to new climate conditions, and this all affects the geological time. And the different processes that we go through in order for Earth's changing surface to adjust to the new climate conditions are all based on the following processes: weathering, erosion, deposition, soil formation, and landform development. Earth's changing surface. We're going to open up the chapter on page 845, and we're going to discuss rock sculptures. Right here we have Arches National Park, and we're looking at weathering and erosion caused by flash flooding, and this structure is called an arch. We also have other arches, hoodoos and plateaus referred to as mesas, that we will be looking at in this chapter as well. Weathering and soil. To begin our section on page 846, the first bullet point, you should already know this. Chemical change results in new substances being formed. So before chlorine, if I drink that, I'm not going to survive that. It's going to kill me. It's bad for me. If I were to eat metal sodium, it would have some type of an explosion and again would be bad for me and it would hurt me. However, I could mix those two things under certain conditions and make a brand new compound, NaCl or sodium chloride, and I now have table salt that I sprinkle on my steak, and at least right away it doesn't hurt me. So, chemical change results in new substances being formed. This part hasn't changed. But something you may not have considered: weathering. We always think of weathering as mechanical, things bumping into each other. Well, we actually have chemical weathering that happens, and because it is a chemical reaction which causes a chemical change, we actually get new earth materials from this. So I'd like you to brainstorm for 30 minutes. This is actually an in-class project. You won't need to do it now, but be thinking of the words weathering and soil. Earth's changing surfaces. Take a look at the car, the peeling paint, the road. What process was responsible for weathering the materials shown here? Water, heat, ice. These are just a few things. What type of climates might be responsible for these particular weathering agents? Temperate climate, arid climate, and an Arctic climate. So throughout this chapter, we will discover the role of weathering in recycling earth materials, differentiate between mechanical and chemical weathering. We will understand natural processes for soil formation, as well as methods to control soil loss. Have you ever noticed the mud puddles after a powerful storm? The corners and edges of rocks, such as this granite shown here, are more rapidly weathered than smooth rock faces. We call that spheroidal weathering because of the sphere-like shapes that result. And you can see here almost circular in formation. And for us locally, elephant rocks would be a very good example. So let's talk about weathering. Weathering means rocks are constantly in change. There's 3 different types of processes that lead us there: chemical, physical, and biological. First of all, physical change. That means the size or the shape of material has changed. Chemical change. A chemical composition of that material, due to its weathering, has now permanently changed. Everyday weathering. That means the weathering processes are in action every single day. For example, the paint on the house, roadways, metal. Each event takes place at different rates, and the reason why they take place at different rates, one reason can be climate. Different types of climate can affect the rate time. So identifying misconceptions, weathering and weather, exactly how are they different? They're really the same thing, right? Take a moment to draw this out in your notes and add 3 or 4 ideas to both sides and decide if you really know the difference between weathering and weather. Pause now. Now, compare your notes with what I have, and if it looks great, fabulous. If it doesn't, you'll want to change that a little bit because this is actually a major misconception in the science world. Weathering actually means the breakdown of Earth's surface materials. It involves water, wind, ice, and it's dependent on the weather. On the other hand, on the right side of your screen, we have weather. That means the condition of the atmosphere at any given time. This includes variables such as temperature, humidity, wind speed, wind direction, and precipitation. Mechanical weathering. It's a physical change that takes place. Rocks are broken down into smaller pieces. The chemical composition of those rocks, whether they're still large or now they're very small, remains the same. That does not change. Force causes physical change, collision with other rocks, turbulent waters, frost wedging, and of course, something that we don't really think about, but is a large part of mechanical weathering, plant and animal activity. What is frost wedging? This may be the first time you've heard of it. Earth's surface can be broken apart. Water collects in the cracks of a rock and freezes. Frozen water expands and forces the rock apart. Melting and freezing cycles cause large cracks to permanently break a larger rock into smaller sections. Biological activity. Water and nutrients seep into the cracks, allowing plants to root themselves, and as those roots grow bigger, they force the rock apart. As far as animals are concerned, we have lots of animals that like to burrow into tight little places, and they travel through or on top of the rock and soil and loosen the materials. Here's a picture of mechanical weathering. Take a look at the cube on the left and the cube on the right. The cube on the left is very smooth, while the cube on the right, as you can see, has all these little divots inside of it, all these extra little sections. So if I asked you which one has the greater surface area, you would probably tell me they look the same, but they really aren't. This surface area is completely flat, but because this one has sections on each side of each one of these tiny little cubes, it's exposing its inner surfaces now, which increases this one's greater surface area. So we've talked about mechanical weathering. Now let's talk about chemical weathering. Take these red rocks for instance. Oxidation of iron-rich minerals, weathering forms red-colored soil, and chemical composition of these rocks has forever been changed. A chemical change that causes the breakdown of rocks on page 848, if you'll follow along in your book. It's caused by chemical reactions between rocks, water, and oxygen or naturally occurring acids. Chemical weathering can also add nutrients to soil that our plants need to grow. This also affects marine environments. Compounds dissolve in water and form ions, and those ions are carried by rivers and streams into oceans and used by marine organisms. They help in building the shell of those organisms that are required to dissolved materials, such as calcium ions and bicarbonate ions. These living organisms, once they recycle back into the ecosystem, eventually make limestone, and the cycle continues over and over. Oxygen, something so simple, we don't even think about the dangers or the possibilities of oxygen. Oxidation, need to know this one. It's a chemical reaction that occurs when iron-rich rocks are exposed to oxygen or water. Iron ions plus oxygen equal iron oxide compounds. Rust equals iron and steel plus oxygen plus water. The mineral hematite, Fe2O3. This causes iron oxidation. It's produced when iron and earth materials react with oxygen, and it's used in steel production. What is the most abundant mineral within Earth's crust? Silicate. It's known as feldspar. Hydrolysis. What is that? Well, it's an important chemical reaction between feldspar and water. It helps form a clay mineral called kaolite. And here we have that same mineral. And when it comes into contact with water, it helps soil store water and absorb nutrients, break down other minerals, and develop nutrient-rich soils. Carbonic acid. Water reacts with carbon dioxide in air or soil. Carbonic acid is considered a weak acid. It reacts with calcite, and because of that, it weathers limestone to form underground caves, such as the one you see now. Take a look at page 848 in your book at Figure 3. Examine the rocks in the picture and recall Mohs hardness scale and the 3 major types of rocks. Why is resistance to weathering based on a combination of factors? Please pause the tape now. Okay. If based on rock type alone, rocks made of soft minerals would be easily weathered, but limestone bluffs and cliffs indicate otherwise. Limestone is resistant to weathering in the arid southwest, but not in the humid northeast. Thus, climate must be considered as well. So let's talk about weathering rate, because again, this is one of the processes. Rocks weather at different rates. Climate factors, temperature, precipitation, evaporation. What about rapid? Areas that have warm, wet climates, cooler climates with freeze and thaw cycles, and slower weathering rates. Slower rates are from warm and dry climates. For example, the desert. You may have also heard me refer to arid, A-R-I-D climates. That's what we consider a warm, dry climate. What else can affect the weathering rate? Well, rock types. Limestone, such as calcite, weather more rapidly than granite that has quartz in it. And of course, landscape. Rocks on steep slopes are more susceptible than rocks in flat, low-lying areas. Your review for this first section is done. Please have your notes ready.